So let's look at another example, but this time we're going to have a murphree efficiency imposed upon us. So the trays have been evaluated, and for our system they have a murphree efficiency of 75% based on the vapor. Now I've drawn in the operating lines based on the original system. I did change my reflux ratio to something so that I'll have more space to draw, so you'll be able to see better what's going on. Now, our definition for the murphree efficiency based on the vapor phase is Yj minus Yj plus 1 over Yj star minus Yj plus 1. So Yj is what I actually have coming off of tray J. Yj plus 1 came off of the tray below. Yj star is what I would have coming off the tray if I were at equilibrium. In this case, I'm saying that this value is equal to 0.75. So what that tells me is that if I measure the distance from here to equilibrium at any particular point along here, that what I actually am going to have is only 75% of the way up. So I can visually estimate that, and it looks like a point about there, and I can do this just point by point and visually estimate where 3/4 of the way is. It's a slow, tedious process, but I'm measuring always in the y direction because this is based on the vapor. If it were based on the liquid, I would be measuring in the x direction, but here I'm measuring in the y direction, 75% of the way between my operating line and my equilibrium curve. And I sketch in what that pseudo-equilibrium line is going to look like. Once I have that done, now I continue to draw off my steps. But I only go as far as this pseudo-equilibrium line. And I hope at this point you're seeing why I gave myself a little extra space. I wanted you to be able to see that I'm going only to the pseudo-equilibrium line and not the actual equilibrium line. Now the number of stages that I get as a result of this should be more than what I had before. Okay, so this required 1, 2, 3, 4, 5, 6. My feed is at stage 3. And if I have a partial reboiler, then stage 6 is really the reboiler, and that means that it is not subject to tray efficiency. So that last step would actually come all the way over to the actual equilibrium line and down. Okay, because it's not subject to equilibrium. So this is a reboiler. It is external to the tower. It will in fact reach equilibrium, so I do not step it to the pseudo-equilibrium line. I hope that this, plus what we went over in class, helps you to gain a fuller understanding of how murphree efficiencies can be used.